Hello everyone, welcome back to my channel. From today's tutorial, I'm going to show you the basic instructions about how to use KiCAD to create your customized device footprints and symbols. The reason for this tutorial is that you cannot find every device's symbol or footprint on the web. So if that's your case, this tutorial will be super useful for you. And if you don't know how to use KiCAD to design your customized PCB boards, you can refer them to the previous videos I've created. They are all on my GitHub channel. So without further ado, let's get started. And today I'm going to use this ultrasonic distance sensor as an example to show you how to create a symbol and footprint for a new device on KiCAD. And so let's go back to KiCAD. So this is the footprint I've created for this device. And as you can see, it looks pretty similar to the physical device I was just showing you. And so let's start with a new project to get started with it. I'm going to close all the windows here. I'm going to discard my changes. And yes, so the first thing you need to do when you are messing around with a new device is, of course, to create a new symbol. Okay, because you need that symbol in the schematic for you to show how are you planning to connect that device to the existing board which you've made. Okay, so let's double click this symbol editor and okay, this opened. And I can find the symbol that I've created for this ultrasonic sensor, which is here with the name of HCSR04. Okay, this is the symbol I've created for this device. So I'm not gonna use this one anymore. Separately, I'm gonna first create a new library for my tutorial here. Okay, so I'll choose global so that for every project I'm gonna create in the future, I can use my symbol that I'm creating right now in the future. Okay, so I'm gonna name it, or the first thing I'm gonna do is to create a new folder. So this one I would say HCSR04 new. And here, let's say this symbol will be named as HCSR04 new. And click Save, and you can see that on your left side of the toolbar or this tab, you can see like there's a new option here showing that HCSR04, right? And the next thing I'm gonna do is to create a new symbol. And it says like no symbol library selected. Let me see. Okay, so what I'll do next is to right-click on this HCSR04 new library and to create a new symbol here. And I'm gonna name it as HCSR04 new. And I'm gonna derive it from existing symbols. And for this reference designator, you need to check like what device are you messing around with. And if you don't know what that means, you can search that on Wikipedia. Here's the page for reference designator. And there's a table on it saying like what kind of components are matched with these kind of designators here. And there are also like modern usage of them. Okay, so for example, if you are creating a symbol for the microphone, you need to like set its reference designator as MK here. Okay, and but as you can see, like there's no such thing for ultrasonic sensor or just sensor here. So what I did was I just asked ChatGPT, and it says like, okay, there's no like standard for designator for ultrasonic sensors. And it suggests me to do this like with a symbol U. So I'm just gonna stick with U. Okay, maybe U stands for ultrasonic, I don't know. So let's click OK, and you can see like we've got this new window here. And I've successfully created a new symbol under this library, HCSRO for new. Okay. And now what I'm gonna do is to create the pins for this new symbol. And you can see that there's a icon on the right side of the toolbar here. It says add a pin. Or you can just click the keyboard. You can just click the key P to create a new pin on this symbol editor. And there's pin name and pin number you need to specify here. And as we can see here, let me bring my camera here. You can see like there are 4 pins on the downside of this sensor, and their names are VCC, trigger, echo, and ground, right? And so I will just create pins for those physical pins here respectively. So what I'm gonna do here first is to create a pin, maybe pin 1 with the name of VCC, and click OK. And then I can just left click it and put it here. And then I'll do these for the rest of the pins here. Number 2, trigger, and number 3, echo. I was just clicking left clicking on the figure here, or the on this plot here, because like I've already selected this create pin tool. Number 4, let's trace the ground, and here it is. All the pins are here, and I can select them and press M to move them. This is the same like as the schematic editor or the PCB editor. And the next thing I will do is to create a rectangle to represent this whole body of the component here. So I'm just gonna click this add the rectangle tool and left click here. Oh no, I might not start from here because this end ends with a circle on it. It means like they need to be connected with other wires to other devices, not to this rectangle. So what I'm gonna do is to create such a symbol like this. Okay. And if you want to edit these pins, you can just select it and press E, and here it is. And it seems that I've messed and incorrectly put the pin name with a number, but number with a pin name. So I need to change them back. So this is super obvious because like it's behaving super weirdly. Or you can just double click it with a left click. It's the same as press E. Okay. All right, this is better. I'm gonna move this designator U to the middle of it, and I'm gonna move it like this. And I also want to add a piece of text here, say like this is HCSR04 device. Okay, looks pretty good. And the final step I'm gonna take is to set the cursor or the pivot point of this component, because as you can see right now, this cursor right now is on the upper left part of it. It's not in the exact middle of this component, which makes it feel a little bit weird. So I'm just gonna select this tool, say like specify a new location for the symbol anchor, and click the middle of it. Okay, this feels really good. And what I'm gonna do next is to just press Ctrl and S to save it. And I can just close this window. So for now, for example, if I'm gonna bring it up in any schematic editor, in any of my projects, I can just say like type A for adding a new symbol, and it's it's basically sorted alphabetically. So I'm just gonna find age, raise age, and here you can see like there is this HCSR04 new symbol here. I can just add it here and drag it here, and you can see like it's being perfect, right? I can successfully import this symbol into my existing schematic. Okay. So the next thing I'm gonna do is to create a footprint for this device, for this component, and also for this symbol. The symbol and the footprint, they shall be matched. Okay, so let's close this schematic editor. I'm not gonna save any changes. And now I'm gonna open this footprint editor. And as you can see, like here is the footprint I've made previously for this device. I'm also gonna do the same thing, which is to create a new library first. And says like, I'm gonna set it as global so I can use it in all of my projects in the future. And you can see like its name is being set as something .pretty. Its suffix is pretty because that's the folder's name for your footprints that's gonna be created. So I'm just gonna make it in the new folder I've just created before and rename this as HCSR04 new.pretty. Okay, so you can see like I've already created a new library here, but this library has no footprint with it. So I'm just gonna right click and create a new footprint, and I'm also gonna set the name as HCSR04 new. And for this footprint type, as you can see here on my device, I'm just gonna bring it up again. So you can see like these pins are pointing downward, right? So they are meant to be pointing through your PCB board, and they're gonna be soldered on the other side of your PCB, right? So that means, which makes them through-hole pins. Okay, so I'm just gonna try to make it real quick with my existing board, even though this board is not designed for my ultrasonic sensor. It's still being able to being assembled like this, right? So these are through-hole pins. So that's why I'm gonna choose through-hole for that. Click OK, and here's the new footprint I've just created. And now what I'm gonna do is to create the pads for the through-hole pins on this footprint, and also I'm gonna draw the silk screen layout for the body of this ultrasonic sensor. So let's start with add new pads here. So as you can see here on the right-hand toolbox, there's a tool named Edit Pad. So I'm just going to click it and click it once more here. So it's automatically creating a new pad for me here. And if you want to edit its properties, the thing you need to do is to left-click it and press button E so you can edit it, right? E for edit is all the same in any editors right now here. And you can also just double-click it, and it will also bring this pad property window for you. So what's important right now is that you need to get those physical characteristics of your device here. So you need to measure the dimensions of your device here. And fortunately, we don't need to do these from scratch because we've got Google. So I'm just gonna bring Google and search like HCSR04 datasheet, and perhaps there could be some mechanistic dimensions describing this device's physical characteristics. So here, this is a pretty long and detailed ultrasonic sensor that is datasheet. And if you check the contents of it, there's a section naming like mechanical dimension. Okay, so here you can see like some of these sensors metrics are showing up here, and be sure that you know like what metric it is using for describing this sensor, right? Like it's using millimeter here, so it's the metric system that this datasheet is using. So don't mess it up with those imperial based systems. And so what I'm gonna do now is to draw a simple sketch with a piece of paper, so I can get some more detailed dimensions from my device here. I highly suggest you do this with the help of a caliper like this. Okay, so I think calipers are way better than rulers for these kind of tasks. So I'm just gonna show you, like for example, on this screen here, it is not saying that like how wide this big cylinder is, but it only shows the height of this cylinder, but like not the width. And also this height is including this thin pad on the bottom, but not without it. So all these kind of metrics need to be measured by ourselves. So back to the camera. What I'm gonna do is to use this, set it to the metric system mode. So as you can see here, it shows up millimeter, and clip it and read the value of it. So it says like 15.8. So okay, that's perhaps the width of the cylinder here. So then, like after doing all these kind of things, I've just come up with this sketch here, and you can see like this sketch here, and as you can see, like I've put like nearly all the dimensions and metrics that I'm gonna use for creating my footprint of this device here. And there are also some metrics need to be measured with the other side of the caliper, because like these are being measured. These are the inner side of some distances, so you need to use this side of it to measure it. So as you can see, like with this, I can tell like the gap between the two cylinders is 10 millimeters wide. Okay, so just draw it and come up with a sketch like this, so you get a better understanding of your device. And now we can try to get back to the real footprint creating thing here. Okay, and one important thing you need to do and you need to recognize first is that you need to figure out how like how wide is it between the two pins on this device, right? Because like there are 4 pins on it, and you need to know like what's the width of those gaps on this device. But fortunately, as I've told you in previous videos, most of these devices are being made to be suitable for breadboard attaching breadboards. And you know, like on breadboards, like those holes gaps are exactly 2.54 millimeters. So like as expected, for all the devices designing for breadboard usage, the gaps between these pins are also 2.54 millimeters. That's why I can pretty easily specify the gaps between these pins without using anything to measure it. And there's also one thing that's pretty important, which is to specify a point zero or a anchor on your sketch here. And as you can see, like this device is symmetric. So I'm gonna set the middle point of it with the upper side of the tiny board as the 0.0 or as the anchor. Okay, so because like this is a sketch that should looks exactly like the top view of your device. As you can see, like it fits. It should fit like it should fit the top view of my device. So like I'm just gonna select any point. So like basically like any point can be selected as the anchor point or point 0, but like I'm just gonna select this one for convenience. And afterward, you can then use all the dimensions and metrics on this sketch to specify the coordinates of the points on this device. For example, as you can see, like this tiny pad's thickness is 1.1 millimeter. So then I can know that this point would be 0, 1.1. Okay, because on KiCAD, the y coordinate is on this direction. Okay, it's positive on underneath of it, but negative on the upper side. And for x, it looks like this. Okay, so right means positive and left means negative. And so as we all know, like this device is symmetric, and the gap between those pins are 2.54 millimeters. So I can firstly know that for the second from the left pin here, it should be negative 2.54 divided by 2, which means negative 1.27 millimeters. Okay, and I also have the thickness dimensions here written on it. So as you can see, like here is 1.1, and this black thing, right, on this device, there's a black thing for those pins here. Its thickness is 2.9 millimeters, and these pins are also like extruding out another 1 millimeter. So I would know that the coordinate of this second left pin here should be negative 1.27 and 5. Okay, so that's how it comes up. All right, so let's get back to the footprint editor. And now what I'm gonna do is to type in the pad's properties based on my previous calculation. So this pad's number should be number 2, or should it be? Okay, you can think about like for a while. What's the actual pad number of it here? Okay, so I will just keep it as number 2 here, and as I just calculated, its position x shall be negative 1.27, and y should be 5. And for these pad shape and pad size, these kind of characteristics, I just copied them from the Arduino 小 board there. Okay, I've kept them exactly the same because like those pins themselves are exactly the same. So there's no need for me to changing anything from them. Okay, so you can just copy my characteristics here for any through-hole devices that you are going to use, especially if they are suitable for breadboard usage. And I'm just going to click OK, and then it is automatically moved to the expected position of this figure. And then what I'm going to do is to copy it and paste it. And let's do that for pad number 1, which is the leftmost pad. And for y, it should be still the same, 5 millimeters. But for precision x, I need to minus another 2.45 millimeters based on the previous pad. So this makes it negative 3.81 millimeters. Okay, so there it is. And the advantage of me using the middle lines, the advantage of me using a point on the middle line as the anchor point is obvious, is that I can just simply change this x from negative to positive and set this pad number as 3. And no, I need to copy it first. Okay. And then it just goes like this, right? It's super convenient. So I'm just gonna do it for number 1 as well. Press E. This is number 4. I'm gonna flip it to the other side, and that's it. So here are all the pins that I'm gonna create for this device. And since it only has four pins here, so like I only need to create 4 pads for those pins. So I have a question that's not being answered previously I've raised, is that does this pin or this pad here should be pad number 1? So why am I asking this question? So let's see. After opening this schematic editor or just symbol editor, and let's find this HC, where is it? HCSRO for new. It says that pad number 1 or pin number 1 on this device shall be VCC, right? However, if you look carefully of your device here, and after it's being put as this, right? So it matches with the top view of it. You can see that the leftmost pin of it is actually the ground pin, not the VCC. So because the reason is that I was trying to create a symbol when these cylinders are facing me, but like when I'm creating my footprint, they are actually pointing to the other side of mine, right? So there's a mismatch here, which means I need to edit this symbol here to make sure that its pin numbers here are matching the pad numbers on the footprint. So the first pad for the first pin here, its name shall be G and D, right? And the second one should be echo. The third one should be trigger. And the fourth one should be VCC. And I'm gonna click Ctrl and S to save it. So afterward, if you are trying to connect this device to an existing schematic, you can see like it makes it correctly. Okay, the previous one was wrong. So after this, what I'm gonna do is to create silkscreen layouts for the physical layout or the characteristics of this device. For example, I need to create these rectangulars here to make sure that the space that this device is taking up on the PCB board will be correctly showing up on your PCB editor, and it will also be printed out as silk screens on your actual PCB. So in that case, you will avoid like overlaps on your PCB board, right? You cannot have overlaps of devices on your PCB board. So I'm not gonna go too deep into this thing because like all the things you are going to do is to use this draw a line tool here, select silk screen and draw lines like this. You can just simply draw a line and press the ESC key on your keyboard, And then you can just press it again to exit the draw a line tool. Select this line, press E, and then you can edit the starting point and ending point of these lines here. Okay, so I'm just gonna bring out an example here. For example, as we've seen that this this anchor point is 0, 0. I want to first draw a line from here. Okay, the upper left point of this pad to the upper right point of this pad, right? And as we know that the width of the pad is actually showing up here on the data sheet, which is 43 millimeters. So we know that the x coordinate of this point here should be negative 43 divided by 2, right? And we also know that like it is in line with the anchor point here, so its y coordinate should be 0, and the rightmost point of it should be 43 divided by 2 and 0. And then we can just edit these properties on the footprint editor and say like x should be negative 43 divided by 2, which is negative 21.5, y is 0, this one's 0, and this one is just the opposite of it. And boom, we've successfully created the line of it. And you can just do so for all the rest of those lines on your sketch and copy them here on your footprint editor. I'm just not gonna do this anymore because I've already got my footprint created, so I'm just gonna delete it. Oh, just gonna wait a second. Oh, I think I deleted the wrong thing. Boom. Let me check. Okay, I just found out that I mistakenly deleted the footprint I just created beforehand. So I just finished creating it all over again with this HC SRO for new footprint. And here it is. So what you can do for the next step is definitely not printing it with a PCB machine. In contrast, what you need to do first is to print it on a paper to test whether this footprint fits exactly with your physical device. So what you can do here is to click File, Print, and you can just it comes up with this new window here, and you check the boxes for FCU, BackCU, F and B silk screen, and edge cuts. And make sure the scale is 1:1, so like it will print out a exact same scaled physical device on your paper. Okay, I'm not gonna click print because as you expected, I definitely printed one beforehand. And here is what it looks like. Okay, let me check. How can I make sure? Okay, yeah. And after it's being printed, you can just go ahead and see if these pins match your physical device. And on the top view is the silk screen matching your physical device's outline. And I think it looks perfect, right? Looks perfect here. So I would say this is a pretty successful footprint that I've created. So I'm just gonna click Ctrl and S to save it, and that's it. So right now, if you want to perhaps create a new project, I think I'm just gonna put it here and say HCSRO4 demo, create, save, and you can import the symbol you've just created as anything else. And for example, if I want to use the Arduino shell board, shell demo, put it here. And for example, if I'm gonna just put the echo here to D2 and trigger to D1, I don't care actually, and VCC here to a external VCC, and gonna bring the powers here and say like VCC and G and D ground, right? And I'm just gonna ground it as well. Remember that we can use these labels, no matter powered or others, to represent our connection here. So rotate it, move it, connect it to VCC, copy it here, and attach it to the 5 volt here. Use N. Okay, and G and D. Okay, I'm just gonna do it pretty roughly. Okay, all right. So this is a pretty okay schematic, and we can just do some footprints here. And here, this UE represents for our ultrasonic sensor. So let's go to here, HC. Don't do any filtering and double click. And U2 is for the demo shell. Double click. Click OK. Let's go to the PCB view and import them. Update. No error. Perfect. And you can see like it is showing up that these pads shall be connected together to the to your device here. Okay. And I can definitely rotate it to make sure like these, what you need to do next is just to route the wires, route the tracks here to make sure like those corresponding pads are being connected. Okay, so this looks pretty simple, I would say. So I'm just gonna stop it here for footprint and symbol creation for your customized devices. Okay, and I also want to mention a few more tips about your custom PCB design here. Okay, because I just noticed this right after me printing my first iteration PCB immediately. As you can see, this is my my first iteration of my PCB board, which is what I made with KiCAD before recording this tutorial. And you might notice that these surface mount soldering devices here are super difficult to be soldered on this board. The reason is that, as you can see here, these tracks connecting to the surface mount soldering pads are super tiny and thin, and also like since I'm using the ground plate, which means like all the rest of the plate with copper on it, well, with not being lasered off, represents the ground node. So it makes these pads, especially for those surface mount soldering pads, super difficult to be soldered, because what you need to when you need to solder it, you need to have a tweezer here, right? Like put the device on it, but like your right hand need to use the soldering iron to heat up the solder beneath it. And since these pads are super small and these tracks here are pretty thin, it is super difficult for you to accurately put those solders on the pads without touching all the ground planes and anything else. Okay, so this is definitely something you want to avoid when you want to do hand soldering. If you are using heat guns or any kind of soldering masks, this is definitely like avoidable. And in the meantime, you don't want these right angles occur on your PCB board, because like if you are soldering it like this, those solder are super difficult to be attached on your track without touching the ground plane. Okay, you want those angles on your board to be obtuse, like every single of them shall be obtuse, instead of like using right angles. So do avoid that. So, and yes, there's another thing for this board, which is, as you can see here, there's a drill hole on the board, but these tracks, or like this should be one track, but it is being separated by this drill hole, and it's totally being cut off, and this wire is broken. So it will be super difficult for you to fix it. I tried to fix the upper track of it with using a wire to be soldered on both sides, and I had to use tapes to glue it on the board, and then I need to use the tweezers and soldering irons to solder both sides on the track. It will be super difficult, so do avoid that. Please make sure that your tracks goes far away from any drill holes on your board. As you can see, like this track here is super dangerous, right? Like if that drill hole is a little bit bigger, this track will be also cut off. Okay, so please avoid those things. And so what I'm gonna do next here on my PCB board is to show you how to avoid such things. Okay, so first, make sure that these tracks connecting to your surface mount soldering pads to be go straightly. They should go straightly to your pad instead of using such an angle. So I'm just gonna, just gonna get rid of all these, and let me see if it is. Yeah, I'm using the correct power. Oh yeah, because I was using this draw line but not this. Okay, so I would like to rotate like this. Okay, so if that's the case, there won't be any problem. And as I've just also mentioned, like this wire is too thin for you to do surface mount soldering. So maybe I'll just remember this, like net D1 to A, and I'm gonna just add this net D1 to A. Okay. And I'm just gonna add that to the class and make sure. Okay, so now, no, is it being thicker? I got it. Net hyphen parenthesis D1 hyphen A, right? Oh yeah, power. Okay. Yeah. So this will make your will make your surface mount soldering to be easier. And also for this one, I'm just gonna route it in maybe in this way. So don't use a angle, but make sure that it goes there like this. Okay. So if it's like this, like you can solder, you can put the solder on either track if you want, right? And also like this is a ground pin. So if you are messing around like making the solder like all the way connecting with the solders on it and make this pad to be connected to the ground plane, it's okay because it is just a ground pin, a ground pad. Okay, so it doesn't matter. And let's check if there's any other hard to solder surface mount soldering pads. I bet this one should be it. So net to D2K. I will also set this one as a thicker one. Okay. And this bottom one, yeah, I think this bottom one should be easy to solder because like there's no ground plane like rounding it, right? Like all these things are being cut off. So it should be easier, but I'm still gonna set this buttonnet class as power. Okay, so should be /BT. Okay. Okay, nice. All right. I think this one is better, definitely better. And as you can also notice that they are wires like this, which is super close to the drill hole here. So I'm definitely gonna avoid that because that was hurting my previous board iteration. So I'm just gonna delete this one here and reroute it like this. It's okay that these tracks are being a little bit close because like you can control it. You can just like use a tweezer or anything, or any other tools to clean those gaps between those tracks. Okay, that would be easier. But like if your track is being drilled and being cut off, you cannot save it at all. So let's do it like this. Make sure it goes from here. Okay, this one's better. Oh, and this is definitely something you need to avoid. So and perhaps a little bit closer, like this. Okay, I would say like this more, and here, definitely avoid this. So I'm just gonna put it like this. Try to avoid any too close situation from your track to the drill hole. And I think that's it. And the last step is, of course, do the DRS checker again. Run it. One error was this error. Unconnected item, because we are not connecting the pads between these buttons. Remember, so just like there's no need to worry about that. And boom. Yes. And now, like as you can see, like the ground plane has been updated, and it looks perfect. I would say I like this one better. I'll just click save, and this will be my new PCB board to be printed out. And of course, remember what's the last step to do? To plot, check include the layers here, edge cuts, no need to get this, maybe no need to get this at all. FCU, BCU, physics screen, edge cuts, I think it's okay. To plot, done, generate drill file, done, and then I'm just gonna go to this folder to check whether my generated Gerber files are there. Okay, it is there. As you can see, my generated Gerber files are there, and boom, perfect. Okay, so that's all for my today's tutorial. I first briefly discussed and demonstrated how can you create new symbols and footprints for your customized devices on KiCAD. And afterward, I showed you how to, I showed you some of the tips and situations you want to avoid when creating your customized PCB. And finally, I demonstrated them with the PCB editor. And I think this might help you bring your PCB board to a higher level, and this will make your soldering even more easier. So, okay, thanks for your watching today, and in the future, I'm going to keep updating new tutorials on KiCAD, PCB printing, and also Arduino microcontroller usage. So stay tuned. Bye-bye.